Very well. Hello and welcome to today's lecture. So we're going to continue chapter 5, the objective of 5.2 and 5.3. These are the sections that we're going to cover today. Are finding probabilities when you have x or z value. So finding probabilities for z or given x, and we're going to do the exact opposite. We're going to find x and z when the probability is given. Find z or x when the probability is given. How do we do that? We are on page 1 of 5.2. So let us go over one example. We're going to start by reading one example. In this example, we have a survey indicates that people keep their cell phone an average of 1.5 years before buying a new one. The standard deviation is 0.25 year. A cell phone user is selected at random. Okay, we have randomness. Find the probability that the user will keep his or her current phone for less than 1 year before buying a new one. Assume that the lengths of time people keep their phone are normally distributed and are represented by variable x. Well, how do we find the probability? So what information are given to us? What do we have here? First of all, we know that in this example, we know that the mean is equal to 1.5 and standard deviation is equal to 0.25. 0.25. Note that we have a survey. It means that we are working with a sample. Okay, so our goal, our job is to find the probability that variable is less than 1 year. Less than. So here's a question. Are we going to use x or are we going to use z? Which one? So do I have x here or do I have z here? Which one is a correct variable? Okay. So what do you think? X, z. Very well. Yes. Yes. That's correct. It's going to be actually x. Why is that? Why it's not z? Take a look at the mean, which is 1.5. Remember that last time we talked about standard normal distribution, and we said that we call for a normal, standard normal distribution, normal distribution. We have mean equal to 0 with standard deviation equals to 1. So as you can see, the mean is equal to 1.5 and standard deviation is 0.25. Those are different from the mean and standard deviation for standard normal distribution, which is actually related to your z-score or z value. So we're finding the probability that x is less than 1. X is less than 1. Okay, perfect. So here you can either use your x value or you can convert that using a z value. Then for a z value, we can use your table. So let us convert x into z. Do we have a formula for that? Of course. Remember the formula. Z is equal to x minus the mean divided by standard deviation. We have the mean, we have the standard deviation, and here we go. So z is equal to x, my x is 1, 1 minus, mean is 1.5, divided by standard deviation, which is 0.20. So on the numerator, you get negative 0.5 divided by 0.20. After the calculation, we get minus 2. So z equivalent to x equals to 1 is equal to minus 2. Now what? Remember that you're saying that we're finding the probability less than. So when you look at the graph, it means that you're shading the area to the left-hand side. So you can directly use your z table. In the z table, you have minus 2. You have minus 2.00. So you find minus. So first of all, you have to use your negative z table because it's a negative number. And you find 2 and 0. The intersection between these two numbers is going to be the probability that you're looking for. Very good. Let's take a look at our z table. So our z table, minus 2. So let us just minimize this. So take a look at this. We have minus 2 and 0.00. The intersection between them is actually the area to the left of z, or the probability that the z is less than minus 2. It is 0.0228. So this probability 0.0228. What's the meaning of that? It means that the probability that x is less than 1, or the probability that z is less than minus 2 is actually 2.28%. Since this probability is less than 5%, it means that it is unusual. Since the probability is less than 5%, it is unusual. Okay, now let me show you how to use your calculator and actually calculate this probability for x, also for z. To use your calculator, you have to follow the instruction. First of all, if you're using your x, note that the mean must be equals to 1.5 and standard deviation must be equals to 0.25. And when you're using your z, make sure your mean is 0 and standard deviation is equal to 1. So go to second, vars, then find normal CDF. After finding normal CDF, you need to enter the information that you have. First of all, since it says less than 1, your lower bound or lower limit on the left-hand side is negative 1e raised to 99. It's a very small number, on the left-hand side. And your upper bound is actually just either x or your z. So if you're using x, write down x, or if you're using z, write down z. But for the mean and standard deviation, make sure if you're using z, mean is 0 and standard deviation is equal to 1. Very well, let's take a look at our calculator. Perfect. So for our calculator, you're actually having x. So this is what we're trying to calculate using our calculator. Here we have, so let me write it on the right-hand side. It's easier to read. So we're trying to find a probability that x is less than 1 and mean is equal to 1.5 with standard deviation equals to 0.25. Okay, so let us turn on the calculator. Second bars, find normal CDF, enter. So your lower limit is -1 e to 99. Your upper limit is actually just x itself. Now, since you're using x, your mean must be 1.5 for this example, and your standard deviation is 0.25. Very well, as you can see, by using our table or using our calculator, we get the probability, which is 0.022. So here you have 75, and you get 8. So 2.28%. Now, what if we use our z? We get the same probability. It must be true. So z, we calculated the z to be less than -2. Remember that the mean when you're working with z is 0 and the standard deviation is equal to 1. So the probability that z is less than -2. So second bars, normal CDF. So the lower limit is -1 e to 99, which is a very small number, and your upper limit is minus. Guys, do not use subtraction, -2, and the mean must be 0, and your standard deviation must be 1. So let's enter. As you can see, get the exact same probability. 0.022. And if you round it to 8, so you get 2.28%. Very well, let's move on to the next example. In this example, we have a survey indicates that for each trip to a supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The lengths of time spent in the store are normally distributed and are represented by the variable x. Well, a shopper enters the store. Find the probability that the shopper will be in the store for each of the interval of the time listed below, between 24 and 54 minutes, and more than 39 minutes. Interpret your answer when 200 shoppers enter the store. How many shoppers would you expect to be in the store for each interval of time listed below? So let us take a look at our information. So very well. On page 2. And this is our example here. So for this example, the information given are the average time mean is actually 45 minutes. And the standard deviation given for us is actually 12 minutes. Very well. So what is the probability that a person spends between 24 to 54 minutes in that store? 24 to 54 minutes. What is the probability? And what's the probability that the person spends more than 39 minutes? More than, greater than 39 minutes. Okay, perfect. So let us take a look at the information that we have here. In this case, your mean is equal to 45. And the standard deviation is equal to, let's take a look at the number. Here you have 12 minutes. So 45 minutes and 12 minutes. Part A of the question says, find the probability that x is in between 24 to 54 minutes. And 54 minutes. The second part of the question, B, it says, find the probability that x is actually greater than 39 minutes. 39 minutes. Okay, let us find each of them separately and then answer to the second part of the question. Very well. Here you have the probability that x is in between 24 and 54. Well, let us use our z-table first. So to use our z-table, first you have to convert your x values into z values. Use z equals to x minus mean divided by standard deviation to find z values. Okay, so here you get the probability that here you have 24 minus mean, which is 45, divided by standard deviation, 12. Now you're converting x into z, so you're using z, and z is less than 54 minus 45 divided by 12. You get the probability that your z is in between. Let's do the calculation. Negative. So here you have negative 21 divided by 12, and here you get 9 over 12. So let us take a look at our calculator. Calculate these two decimal numbers. The first decimal number is negative 1.75, and the second value is 0.75. 0.75. Okay, so you're actually finding this area. Suppose you have your normal distribution, 0, 1, 2, 3, -1, -2, and -3. -1.75. -1.75, roughly. Then 0.75. 0.75 roughly. So what are we looking for? We're looking for this area, this probability. So what are we going to do? We're going to use our Z table to find the probability that actually Z is less than 0.75. Then we're going to find the probability that Z is less than -1.75 and subtract. Very well. So let's take a look at our table here. So our Z is equal to -1.75, -1.75, so -1.7 on the first column, -1.7, and 0.05 on the first row. Let's find the intersection between these two numbers, which is almost 4%. So 0.04, the smaller area and the larger area. Very well. So the second Z value that you're looking for is 0.75. So 0.75. 0.75. So if we find 0.7 on the first column and we find 0.05 on the first row, the intersection between them gives you the larger area, which is 0.77. 0.77. We can do the subtraction, and approximately you get 0.73, almost 73%. So the chance is 73%, or the area is almost 73% of the total area. Total area is 100% or equals to 1, and this is just 73% of it. Now, how do we use our calculator? So to use your calculator, since you have X in between, Z in between, it means that you have your lower bound, you have your upper bound. So here, you go to second, bars. Then here, you find normal CDF. After finding your normal CDF, so here, if you're using your X, make sure you're using 45 and the 12 as mean and standard deviation. So your lower bound is now just 24, and your upper bound is 54 with mean and the given standard deviation in the example. If you're using Z, then your lower bound is -1.75, and your upper bound is actually 0.75. Very well, remember the mean must be 0 and standard deviation is also 0. So let us do the calculation. If you have any question, please use chat. You can unmute yourself. Okay. There you go. So we're finding the probability that x is in between 24 and 54. Very well, our mean is equal to 45 and standard deviation is equal to 12. So let us turn on the calculator. Second bars, normal CDF. So your lower bound, your lower limit is actually 24. Your upper bound or upper limit is 54. So your mean is 45. Your standard deviation is 12. Enter, enter. As you can see, you have 0.73. So this is your probability, or 73%. Now, what if we use our z-value? Finding the probability that z is in between negative 1.75. So negative 1.75 and 0.75. Remember that when you're using z, mean must be 0 and standard deviation must be 1. So let us use our calculator. Second bars, normal CDF, and here your lower bound is negative 1.75 and your upper bound is 0.75, and here your mean is 0 and your standard deviation is just 1. As you can see, you get the exact same probability, 0.073 or 73%.